Okay, the last video left off. The last video left off right in the middle of a problem. So this is square root 9 times square root 9 times square root 7. And we figured that out on the last video doing a factor tree. And that ends up being root 9 becomes an integer 3. Root 9 becomes another integer 3. And then we have root 7. So that becomes 9 square root of 7. How about root 68? What is 68 divisible by? You might ask yourself, it's an even number, is it divisible by 4? And if you did the math on that, you would find out 68 is divisible by 4. And when you divide 68 by 4, I believe you get 17. Let's see. So 4 goes into 6 one time. 1 times 4 is 4. Bring down your 8. Yeah, 4 times 17. Remember, you're always supposed to check for 16 if 4 works. So let's just check for a minute. Let's see, 16 times 3 is 48. 16 times 4 is 64. So if 16 times 4 is 64, there's no way 16 goes into 68. So we can use 4 and 17. That's going to be our best bet. So all I got to do over here now is rewrite root 68 as the square root of 4 times the square root of 17. Then I convert that square root of 4 into an integer. That's 2 square root of 17, and I'm done. Okay, root 80. You might think that's 4 times 20, and it is, but you're supposed to check for 16 also. And you probably know that 80 is also 16 times 5. So root 16 times root 5, and that gives us 4 square root 5. Square root 27. Is there a factor of 27 that is a perfect square? Yeah, 9. Root 9 times root 3. This ends up being 3 square root 3, because the square root of 9 becomes 3. Oops, sorry. Square root of 9 becomes 3. So you get 3 square root 3. Okay, let's go on to the next page. Let's see. Let's look at for problem 15 here. We're going to rewrite these with rational exponents. So in class, we just said all you have to do is take the radicand with the exponent and then use the index or the root as the denominator. So I'm going to take x squared right out of there. And then this third root I'm going to put underneath. Okay, I wrote that a little too big, but I wrote that so you could see it on the video. So that's x to the power of 2 with the 2 over a 3. Use the same technique here. Let's take that h to the 7th out of the parentheses. And then take this 11 and put it as the denominator. Okay, rewrite using radical notation. So now we're going to go the other way. We drew the root first. So I want a root 7 because that's on the bottom. And then I want m to the power of 5 inside. The w to the 3/8. I need a root 8. And then I'm going to take w to the power of 3 and put it inside. Okay, my favorite, select the equivalent expressions. Remember that I said when you first start these, before you even look at the answers, you should find some equivalent expressions up front. So what is equivalent to 6 to the power of, fifth root of 6 cubed? Let's go ahead and cover the answers for a minute. And one thing is I can rewrite this with rational exponents. So 6 to the power of 3 over 5. Hope you can see that. 6 to the power of 3 over 5. Another thing I can do is do 6 times 6 times 6. And that would get me the fifth root of 216. Which also would give me 216 to the power of 1/5. That should be enough to get us started. Let's see what happens. 6 to the power of 5 over 3 is our first choice. No, because they flipped the fraction. That's wrong. What about 216 to the power of 3 over 5? Nope, we could use 6 to the power of 3 over 5, or we can use 216 to the power of 1 over 5. This one does not work. It's the wrong exponent. The fifth root of 216. Yes, it works. Look, when we did 6 to the power of 3, we got 216, and we have a fifth root there. Yeah, that one works perfectly. Ooh, 6 to the 1/5 raised to the power of 3. That does work. Because look, we have 6 to the 3/5 right here. And remember, this is power to a power. So if I multiply these powers, how I get, 6 to the power of 3/5. So that one works also. Ooh, what about this one? 6 to the 1/5 times 6 to the 2/5. The bases are the same, and we're multiplying. So we're going to add the exponents. So I get 6 to the power of 3 over 5. That works. 6 to the power of 0.6. I intended that to be a 0.6. I don't know, that's a decimal. What's 3 divided by 5? Yeah, 0.6. That one works too. So the only ones that didn't work were A and B. Number 20. Okay, so before we get too far, let's see if we can write the square root of 9 to the 4th in any different ways. I could rewrite it as 9 to the power of 4 over, this is a 2. Oh, and that reduces to 9 squared. Wait, this is 9 squared? Oh, that's 81. Wow, that's just 81. But you know, I wonder what 9 to the 4th power is. 9 times 9 is 81. Times 9 again. 729. That's only third power. 729 times 9. That's 1. Carry your 8. 18 plus 8 is 26. Carry your 2, 63, 65. Okay, so if I went ahead and did the 9 to the 4th power, I would also get the square root of 6,561. Okay, let's look. My first option here is the square root of 6,561. Second option, 9 squared, because the exponent would be 4 over 2, and that simplifies to the number 2. Square root of 9 to the power of 4. Oh, can you see that? That does work, because we discussed in class that you could take this exponent 4 and put it outside parentheses, and it's the same thing. 3 to the power of 4. You know what? This does work, because look at letter C. Letter C said that you're allowed to do square root of 9 raised to the power of 4. Square root of 9 is 3. So that is 3 to the power of 4. So that one works. Plain old 6,561, nope. 729, nope. And what are we on now? Oh, we are almost done. More simplifying square roots. 325. Oh, and it's negative. All right, we got some i's here. Okay, so square root -1. And I hope you remember that anytime you have something that ends in 25 or 50 or something like that, you should see if 25 is a factor. For example, if you had $3.25, how many quarters would you have? You'd have 13 quarters, I believe. So you would on your own do 325 divided by 25. 25 goes into 32 one time. And you got to borrow and carry here. You get 75. And that's a 3. is 25 times 13. So I have negative 1 times square root of 25, square root of negative 1, sorry, times square root of 25 times square root of 13. Square root of negative 1 becomes an I. Square root of 25 becomes a 5. And square root of 13 stays square root of 13. Negative 300. Hey, I got this. It's negative 1 times square root of 100 times square root of 3, right? 3 times 100, 100. Okay, the square root of negative 1 becomes an I. The 100 becomes a 10. Square root of 3 stays as square root of 3. Negative root 18 equals square root of negative 1 times square root of 9 times square root of 2 equals 3. Oops, sorry, I forgot the I. Square root of 9 is 3. Square root of 2 is 2. 98. What's 98 divided by 2? It's 49. There we go. Square root of negative 1 times square root of 49 times square root of 2. Square root of negative 1 is I. Square root of 49 is 7. And then we have a square root of 2. Good luck on your exam.